That's your toothpick, naturally aspirated rod, yeah.
HoonTV! All right, so it's Monday and another evening here at Footscray Engine Reconditioning, or Horsepower Junkie. And on the weekend we stripped down, well, Thursday when I got here, we stripped down the old mystery engine. So you would have seen that video hopefully. If you haven't, go back, it's quite funny. And then on Saturday I came in, ripped down one of the two FG engines I bought. I grabbed two from a wrecker. Then on Sunday, Anth said, oh, well, let's rip down the other one. And so we've basically torn down three engines in 3 days and hot tanked them, cleaned them, got them all prepped, sort of ready to start machining and stuff like that. So what we're doing tonight is, whilst Pete's finishing a funny story, Anth's sort of laid out some bits and pieces, and we're going to go in and talk about what's happening with this new engine, because I picked up some other parts today, so we're going to rip into it and start looking at how this engine's going to come together. So let's go find him.
I'll see what
We'll throw Pete a crisp high five on the way through here. Yep. Hey, there you go. There he is.
How are we?
And so we've pulled apart three engines, our funny Thursday night job, before we went and had an amazing feed. And now we've got these two FG engines here, thanks to you. Got all inspired and tore down the second one on Sunday, because this guy's a 7-day-a-week engine guy.
Well, with 6 hours sleep, I was
Yeah.
feeling revitalised.
So now we're going to start off basically, and we've got no real official plan here, so this isn't like a tutorial or anything like that. We're just talking about what's going on with this engine. So I've got some shots of you just before here, sonic testing. Or what's the whole process here? What is this? You were explaining it to me.
Yeah, so basically with these blocks, especially if you're going to make any power, the foundation is the block itself. We have to make sure that we've got enough meat on the bores. Number 1 and number 6, even the insides of number 5 and number 2 are usually the ones that let go. So most of our attention as far as, you know, checking 12 to 16 points in each of those bores is what we try and achieve. And all we're looking for is the consistency of the casting. So we're not looking for thin spots or anything like that. We're actually just looking that the bore is concentric to the bore itself. The thicknesses will come and go from block to block. This first block that we measured up, from this point all the way up to number 2 cylinder, so from the back to the front, it's actually very consistent. All the bores are fairly round. We've got about roughly 3 to 4 mil on all the centres, which is normal, and we've got 5 mil plus on the outers. We get to the first bore though, we've got a real thin spot as we run up and track up and down on the bore here. It's 3.1 at the top, goes down to 2.8 down towards the bottom. And we also see that on this wall, we're thin as well. So the bore is almost shifted back this way when it's being cast, and it's just not right. So this bore we won't use.
Yep, so this is a streetcar engine.
Yeah, so once you get down to 3 mil, it's sort of like as thin as you want to get. Once we bore that out, that's going to read more 2.8. Consistency on this as well. You've got a variation of, you know, 0.2, 0.3 on your actual bore reading. So we decide on the error caution. This bore could eventually get down to like 2.5 mil by the time it's finished on the thin side. So
and actually, like you showed me just before, how you measured to make sure that's totally accurate, which is really cool.
Yeah, so every time we do a block, a cylinder head or whatever it is, we don't know exactly what material this is made of. It's come out of a foundry, it's a casting. We don't know exactly if they've used the same batch of material every time they have. So we use this section of the block here at the front as our, basically as a calibration pad, and we use that on every single block that we do. We calibrate our tool on here, which the tool will give us a reading. We'll verify that with a micrometer. Once the two are consistent and we've got the velocity right on that, then we'll go through and measure the block. That's the most accurate way of actually setting it up and doing it.
So now this is the cool part. So when I rang you the other week and said, look, I've sussed out a couple of FG engines, which out of wrecker, so they're proper, like, nice, good, legit engines.
Yep.
Come with a receipt, all that sort of good stuff, not something off marketplace. And I said, look, I'm going to grab both of them. How did I go?
Well, you did well. We pulled them down. They were actually both nice engines to start with. Bearing wear was good. The cranks were good, as we'll have a look at after. The bore wear looks good, which for us allows us to take less out, which is better. The blocks are square. They haven't had a real hard life, and now that they've had 10 years on the road, they're nice and hard. They're rigid. They're settled. they're ready to be machined and turned into something. Yeah.
And now that you've said on this one, so this one's a bit sus and we won't be using this one, how are we with this one here?
Well, this one, much like this one, from 2 all the way back to 5, it's very consistent. But unlike the other one, the first bore itself is consistent with the rest of them. So we know that by starting with this block front to back, we're not going to have any scary surprises with thin spots or thin patches in it. There's a couple of points that you'll see in here, like 100 mil down this bore, we're sitting at 3.6. 20 mil from the top of this bore, we're sitting at 3.7. There's a couple little spots in there. 100 mil down doesn't really worry us because it's not really going to see any cylinder compression down there.
Yep.
And it's not on the skirt thrust side of the piston. Up here though is probably a bit more of a worrisome thing, but if we're not down past 3.5, it's not a concern with what we're doing.
And I mean, you know, we are sleeving this anyway, so...
We're putting some sleeves in. We're also
Yep.
going to back it in with some grout, just
Yep.
to add more rigidity to the bottom half of the block. Yeah, it just stops the bores from ballooning and it gives them a bit more support.
And like when you say grout fill as well, I mean, we looked at another block out there that I could get a shot of in a minute. We're not going full grout fill, so we're still going to be able to run water.
Yeah, so basically the first 50 mil of the piston stroke, which is the top 2 inches, that's what's actually going to see all the heat from the cylinder, and it's going to see the most work from the most temperature from the rings. So we'll evacuate the heat from the first section. Lower down where it's more frictional and it's thrust, that part there will be grouted, but we'll use the oil that's splashing around in the block to cool that.
Yep. Yep, nice. And I mean, the next step on top of this would be going to this over here, which is, as you would have seen already on HoonTV. I think I even filmed this block when it was at Bullet, but we're not quite going this level yet.
No, well that's a drag spec. So this block here has no water at all,
Yep.
And we're purely reliant on the volume of fuel and gas that runs through it to cool it down.
And when we say a lot of fuel, that's like shitloads. So
yeah, so if you can imagine, basically you'll have a tap in each cylinder at full noise, just flowing straight into it.
And for the people that are wondering at home though, what is this billet motor going into? It's a Barra, obviously. It says it's a Pro Mod car or something, isn't it? Or?
Yeah, it's going into one of our good friends' cars, and yeah, you'll see it at the track soon. I won't advertise it too much because I'll let him do all of that.
Yep.
But
at
yeah,
the moment it's just a billet.
We're just purely a vessel. We'll get it right, send it back to him, and then he can advertise it.
Yep. And I mean, while we're over here as well, like I noticed that before. That's just a Speedway engine, like a Commodore V6 thing.
Yep.
But we have the Behemoth RB30. It's even got the Holden rock cover on it.
Yeah, the single cams are still very popular. We do quite a lot of them. The VL turbos are still going strong.
Yep.
But the old diehards really want to stick to a single cam head. So we've done a fair bit of development on the single cam heads. They work well. There's a couple alterations that we're moving into I'll show you later, with different cranks and varying strokes.
Yep. I mean, I noticed this straight away, like crank angle sensor there, and that's all been well plugged up. That's quite cool, rather than having a blank on there.
Yeah, that's right. And then other little things which we get from people.
Don't want to steal too much of your IP though, but Yeah.
No, that's right. It's a crush ring head gasket. It's a good thing. They work really well.
Nice. And moving over here, a little bit of Toyota-ness.
Yeah, so another 2J. This one's a good setup. This is going in a Mark IV Supra. The guy's build spec for it basically was he wanted a very strong, reliable bottom end. We didn't do much head work other than a set of cams. The bottom end's got top of the range pistons in it, a set of PPM rods in it. It has real street billet main caps on it. So, cylinder head down, we're basically, that's a 1500 horsepower combo. The guy though, he only wants to put 500, 600 horsepower on a drive on the street, but he wanted something that's going to last him a long time. So we've kept it steel rod, made everything down low very, very strong, and if he wants to flash it up one day and punch a heap of boost in it, engine's more than capable.
And moving over here, for the one Commodore in Australia that's not going to put an LS in his car, you said this is for a HSV or something like that?
No, this is going in a VK, actually.
VK, oh, there you go, yeah.
Yeah.
So Holden with a Holden engine in it.
A Holden with a Holden engine, yeah, and a steel and a cast iron block, which is quite rare these days. But we still do a number of these. Still very common. The old 5-litre guys still like to build them. Technology's come a long way. You know, I had a call from a customer yesterday who said, "Oh, I've got 112 kilowatts at the wheels in his stinky Holden V8," which he sort of wanted to move to an LS. But the other option is to build what you've got and use all the modern technology with, you know, all the new EFI intakes and whatnot, and yeah, make it a good thing.
And I mean, for you, I've just annoyingly unbagged all of these engines because they were all actually all wrapped up in plastic, so they're all nicely protected, and I've just come and yanked them off to show them off. So coming back over here though, let's so I've just today I've gone and caught up with Thomas from PPM and made some purchasing. The starting point, other than this block, to start from the bottom up. So let's have a look at what we're doing with this engine. So you said before this crank. So I'm really amazed at the caustic bath and everything like that. That crank looks brand new. So this is the crank that was in this engine.
Yeah, if the guys watch the video of the strip down, they'll see what it looked like beforehand. It was a brown turd, but yeah, the caustic just tears all that off and gets to the bottom of it. Yeah,
and I mean, obviously, we could be using this crank, and like in the past, you and I had discussed the heat treating of cranks and stuff like that.
Correct, yes.
And yeah, I mean, we could go down that path. I mean, what's the advantage of heat treating that crank if we did stick with a standard one?
Well, basically, just once we put a very hard skin on this crank, what it does, it promotes better oil flow on the bearings, and it prevents the bearing from galling on the pin, and it allows the wear resistance of the crank to be much higher. It also adds a little bit of strength, but that comes with other things too, us opening the radiators up, polishing the crank down, shop peening it. They're all more strength adders.
Yep.
But yeah, all those combined make a really good crank, but once you start doing all that work to these, you know, it becomes quite an expensive operation, and they're really, once we do all that work, they're not much less than stepping it up to a billet crank. The other thing too is if we build an engine for these, once we go over 1,000 horsepower, we won't warranty it if it breaks. Yeah. And that's purely because we still crack testing, but we can't get into the middle of the crank and have a look at the grain structure.
And I think you said the other day as well, like, I mean, this is a pretty nice looking crank, but in some instances you were saying you just go and buy a brand new one from Ford as a starting point, because
again, we don't know the history of it. We just don't know the history at all, and this could have, we can test the surface of it with the equipment that we've got here, but what we can't test is down in the middle of the core. If there's an air bubble, if there's a pocket, if there's a crack starting to form, we just don't know.
Yeah. So, and that's where, like you've just mentioned, we could like spend a heap of money on this crank, or we could just go to this, which I've picked up today. This is my new crank, prior to getting some other work done to it, but this is the PPM crank. So explain to me what model crank this is and what we're going to be doing and how much power this is good for.
Yeah, so this is a 4340 steel crank. One of the benefits that you can see quite quickly, actually, if I roll it over this way, is you've got no counterweights here, and here you've got counterweights. So it's a fully counterweighted crank.
Yep.
What that means is it's going to have more stability at RPM, and the crank's going to have less flex, especially off these two pins, which keeps it running more true. It also allows your main bearing clearance to run a bit tighter, which will sustain more oil pressure and less wear you'll have. That's probably one of the biggest benefits. The other thing is strength. This crank's physically heavier than this crank, and it just comes down to material density. They've squashed more material into each cubic centimetre in this one than they have in that one.
Yep.
A couple other little advantages. This crank's designed with a long balancer bolt that comes all the way in, and it actually locates in the front of the snout, taking a lot of load off the snout. So if we're going to run additional drives, you can put that in. If we're going to run additional drives off the end,
that's as far in as the bolt goes. I'll put my fingers there. Oh no, actually I'll do it this way around so you can see. So this one goes all the way in there. I think it's actually got a bit of rag in there or something like that. But that's all the way in there, showing that far. That's how far the bolt goes in. And that's as far as that one goes in.
Yes, it's almost double the distance.
So you've got that big balancer hanging off that much of the crank there. there, whereas this one's like all the way, that bolt goes all the way into the front bearing. Yeah, wow.
Correct, and it's all about rigidity. So the reason why we go for a heavier, stronger crank is purely rigidity. It's core rigidity, it's rigidity at RPM, and it's RPM harmonics that we try and get rid of as well, because we can balance these two cranks and balance them out to zero.
Yep.
But the dynamic harmonics that they get when the engine's running is different again, and we can't solve that problem.
And just out of interest, I mean, I watched you with a crank on the crank balancer before, because I mean here, like we're literally in the engine room, and there's a full machine shop out here. So this is like, and everything from like, you know, massive diesel engines right through to all this cool performance stuff. I mean, I know the guys out there get a bit excited about diesel stuff too, but because this one isn't counterweighted on 2 and 5, is it? Yeah. Mm-hmm. How do these like go on a balancer then? Are they a bit of a...
No, it's not an issue. So an inline 6, an inline 4, even an inline 8, all of them are balanced through the centre axis, and they don't require bob weights to be added on to the actual crankshaft itself. And that's because all the pistons run up and down in the same direction. Once the pistons start changing directions, it adds more dynamic load to the crankshaft, and at that point, you've got to have additional counterweights, and you've got to also put bob weights on the crankshaft to counteract that. On an inline, we don't have that problem. So you look at an early Holden, for example, it doesn't have any counterweights on it at all. It purely just, and a lot of the diesel ones like here are like that too. They'll just follow, the casting will just follow the pins with no counterweights on them. But they're not designed for high RPM. They're designed for low RPM, high torque.
Nice. Well, so this is what we're running. You did say that we're going to be adding a Torrington to the front of it.
Yeah, so this is out of the box. We still have to modify the crank. We are going to run a Torrington because you're running a Turbo 400. And this crank will, as you load it up with the converter, it will want to balloon and shunt forward in the block. The Torrington simply just prevents the whole crank from moving forward. We still run a thrust bearing in the centre, which again prevents it from shafting back the other way. It also protects the oil pump because we're going to run an oil pump on this motor. And on the back side, if you want to come around this side.
And just out of interest, like Torrington bearing's not anything that's brand new. It's been done for years, hasn't it?
It's been a long time. We started doing Torrington bearings on Windsor engines, you know, like back 10, 15 years ago. So
so no one sort of invented it in the recent years, have they?
No, not at all. No, it's a very old technology. But it's been brought to market, so more people know about it now. Yeah. On the back side here, we're going to add some dowel pins in. We'll drill and tap that. We'll put our dowel pins in. That will suit the flex plate that you're running, and prevent it from galling, because it is a very common problem with these, especially when you start making big power and loading the tyre. All that weight transfers through, and it shunts the flex plate off the back. Yeah,
and I mean, even that's very similar to what I did with my Land Cruiser recently with the axles. It's like I've got these flange billet axles that I've got 6 bolts and then 6 extra dowels in them. Yeah,
you'll notice all of that. So like I said, this is new out of the box. We've still got to machine the front, we've still got to machine the back, and then once we do that, we'll send it back out for hardening again, just to make sure that it's been case hardened properly.
And then we might even give it a polish up.
Yeah, and we might even get a polish up to shear the oil a bit better. And then, that's ready to go in the block.
And just now while we're here, like, I mean, we did actually unbox these because you've got a few in stock as well. Bit of PPM goodness here. What are we looking at on the bench here?
So these are a couple projects actually that we've got going on. This one here is a 2J, but it's a 3.5 stroker for a 2J.
Okay.
Basically like a street series motor. In the 3.5, they work really well up to 1,000 horsepower. Like for anyone that owns a 2J, they'll know loading in a 42 with 3 litre capacity does make them a little bit lazy down low. This really wakes it up and brings it to more of an enjoyable car to drive. This one here is a 2.2 stroker for SR20. Quite a flash looking crank.
Yeah, very nice. They look cool with this knife edging on here. It's like
they do. So the SR's quite That's actually quite similar to the OEM design, but the material's much better in these cranks, and the oil gallerings have changed. So everything's straight shot oiling, which is what we want. It's what we use. We don't really like cross drilling. It just doesn't seem to work as well.
Yep.
And this one is a special project that we've been working on, which is a 3.4 RB crank. And these are going to go in a couple single cam motors that we're doing. And the boys just want to go fast in the single cam, so we'll give them something to play with.
Nice. Nice, all right. And then there's a whole bunch of rods over here as well, but we'll get to that because we have some over here. So we're looking at, I mean, there's always been that Barra rods, the BA early ones with the toothpicks. So this one here, this is a FG aspirated rod?
No, it's a 1R.
Oh, okay, what's this one? So
1R is an early series rod.
Yep.
Found in an FG motor,
yep.
of all things. So it's
so that is your toothpick there?
That's your toothpick, naturally aspirated rod,
yep. Yep, and that's also a naturally aspirated piston because it's only got the 2 fly cuts in it and it's higher comp in that?
Yeah, correct.
How much compression are those ones?
And it's not running a floating pin either. So.
No, and for people that don't know what a floating pin is, as well, that's where the pin moves with the
if I show you,
pressed into the conrod.
If I show you in here.
Yep.
So if your conrod's actually got a bush in it,
yep.
The conrod's actually designed to move freely on the pin,
yep.
Independently. Where this one, the conrod's fixed to the pin through being shrunk fit on there, and then it actually, all the articulation happens in the piston. So you really want to make sure that gets lubricated properly, because if it doesn't, that will seize up and grab.
Yep. Now, and I mean, obviously, I'll just mention PPM as well. So we've got the PPM rods and pistons here with the cool logo that kind of looks a little bit like he's copied my tattoo on my arm. But yeah, I've had that tattoo for a long time as well, so I reckon he's ripped me off. Yeah, so I haven't had my tattoo trademark though. But so yeah, so these are what model rod and piston have we got here, and how much comp and how much power is this going to be good for?
Yeah, so this is one of their forged rod variants. We've decided to go for steel rod on your build, because basically we want a bit of longevity out of the motor. We want to give you multiple applications to use the motor with, and we don't want to go tearing it down every 5 minutes. The other issue is this design piston that we're using doesn't allow enough meat in there to run an alloy rod on it. It gives you enough rod articulation with this rod, but if we go and change that, we'll have to machine and modify everything to suit.
And I mean, when you mention alloy rod, I'm just going to grab this from over here because I just happen to have, here's one I prepared earlier.
Yeah.
I mean, there are obviously advantages of an alloy rod, but what are the disadvantages? Like you've just mentioned, that rod's only got a certain lifespan, and
just aluminium in general has a lifespan.
Yeah.
And look, all of these rods have a lifespan. They'll all have a fatigue life. Just this is going to come a hell of a lot quicker than any of them. Even if we put this in an engine that was making 200 horsepower, it will eventually receive its fatigue life, and it'll probably be very similar to when this rod does. So
yeah, and I mean, when you mean that, like there's a cylinder head here, that's aluminium, but that's different because that's under push-pull load, so it's getting stretched and crushed all the time in an engine, whereas the head's just doing its job.
Well, the head's a bit different because the head's getting clamped at 4 points. It's fabricated. It's braced with all the oil galleries and internal structure in that cylinder head.
Yep.
And only this portion of the head really is seeing full cylinder pressure, and that portion of the head is getting relieved every time the valves open and close.
Yep.
So the load on that cylinder head is a hell of a lot less than what this poor guy's under.
So, and I mean, this rod and piston here, this is going to be good enough for like at least 1500 horsepower or whatever anyway, isn't it?
Well, that's what we're aiming. We're aiming for the 1000 kilowatt build with yours. And as a 1000 kilowatt build package, this is more than enough. Yeah. Yep.
And I mean, it's a pretty tough looking piston.
Yeah, it's a nice little thing. It's going to work. It's actually going to work really well. We've used these before. We put these in all our street engines, and they work flawlessly. We haven't had one fail on us yet.
All right, well, moving on to here. So we have what looks like a fairly stock-looking Barra head, but it's not. What's the deal with this head, and how similar is this going to be? Because this obviously, mine's out on a pallet out there, all shiny, ready to get pulled apart.
Yeah, so this is a basic street port cylinder head. It's a CNC port variant. It's a BABF early style cylinder head. Yours will be slightly different than this because we'll have a larger valve setup in it, which means new inserts, and you're going to have a dry deck cylinder head as well.
Yep.
For anyone that doesn't know what dry deck is, it just simply will plug up all the water holes on the block.
Yep.
And we'll reroute the water so this face doesn't see water, and that's just purely safety. We don't want this head to lift while you're drag racing it. If it does, push water out the side, and then onto your back tyres and put you into a wall.
Yeah, yep. And then basically, so instead the water's going to come out of like a dash fitting outside or something like that, isn't it?
Yeah. We'll weld some fittings on the head, we'll weld some fittings on the block and marry it all up and reroute the water.
Yep.
So yeah, like I said, this is a street port. This is the smallest port we do. This cylinder head will easily flow 1,000 kilowatts, but with yours we want to do something a little bit different and step it up, because we want to make the similar power numbers but at lower boost thresholds to make the engine last longer.
And I mean also, like, you know, I've shown on my videos now that I've got the GTX 55, which is a big ass turbo. So obviously some of this engine build's based around that turbo and combo and stuff like that as well.
Yeah, well, it has to be. That's why we're changing the cylinder head, and not normally on a 1,000 kilowatt build would happily put one of these heads on it. But because you've got the bigger turbo, the bigger rear housing, we need to put more in there to get it to breathe better and work better. We're keeping it 4 litre.
Yep. Yeah, and we didn't mention that too. We're not de-stroking, we're just sticking with the standard
No,
stroke.
we're sticking with 4 litre. We're going to
Yep.
put some more RPM into it. That's why the head's going to have a heap of development. The valve train will be really trick on this head as well. And that's so we can rev the 4 litre and utilise the turbo that you've got.
Yep, and I mean, unlike, you know, like this billet block over here, which is a full dry sump engine, moving over here, I'll move this out of the way. This has got some other goodies in it. See, horsepower junkie.
Yep.
Talk to me about oil pumps. Most people know about your billet oil pumps, but let's have a look at the standard one here.
Yeah, so this is actually the one out of the engine. We put that through the tank, given a clean up. It's come up quite trick.
Yep.
You can see that it's actually how good the engine was. It's only got a few tiny little marks here, which you can barely grip with your nail.
Yep.
Besides that, the pump housing is actually really nice.
Because those two engines kind of look like a bit of a Mar and Par engine out of just a everyday boring FG.
Well, for the people that don't know, why I find this impressive and I get excited about this is because this is pre-filter. So whatever's going through the engine pre-filter will end up in here, and basically most of the damage that you'll see through here will tell you how well the engine's been looked after.
Yeah.
The fact that it looks so good tells me that, you know, they actually cared about their car. So.
And I mean, these two engines, from memory, I think one had 240 and one had 260,000 kilometres on it. So that's pretty. And I mean, you say pre-filtered, it's still got like the mesh in the pickup, but that's about it, isn't it?
But it's very coarse. It's basically a very coarse gauze mesh, and it will still allow products, you know, half a mil in diameter through. So it's still very coarse. Enough can get through that it will gouge up the housing quite badly. I've seen it much worse than this.
Yeah, so, and that's the thing, I mean, so now, most of the time, in the past, people have been putting new oil pump gears in there. Like, we don't have gears here at the moment, but I can throw a picture in, but gears and then a billet backing plate.
Yeah, and often you'll get people trying to get in here and port it all out. We don't really necessarily agree with that. And simply, if you look at this ridge here, and then measure it through this section here, the pump housing gets very thin. The material this is made of is just a cast aluminum with a very low tensile strength as well. So once you get in here and you start porting all your ridges out, the housing gets so thin. It's also bolted at this point too, which causes a moment of inertia, and that housing just wants to flex and walk. On this side of the pump, again near this thin section here, you've also got your pivot stud which runs your timing chain off it. So there's a hell of a lot going on right in this section of the pump, and you really don't want to make that wall too thin if you do the pump housing split. And I think a lot of people have seen videos online from pump housing splitting here. The other thing too, people jump in here and they modify all this bypass section as well. We don't do that purely because the wall section here that guides the little check valve that runs up and down is only it's only a quarter on each side there. So once you start getting in here and modifying too much, the little check valve can twist. And once it does twist and jam in here, with the housing flex, you'll have your check valve remaining open and you'll lose all oil pressure entirely.
Okay, so we're not using this one, even though a lot of people are.
And that's still fine to use. So if you had a good street combo, that really you hadn't gone and messed with your bearings and you haven't opened up the clearances and you haven't played with it too much, and or if you had that you've reset it all back to OEM, this pump's more than fine. Put a set of gears in it. Again, when you do your gears, set your backlash, measure all your clearances, which a lot of people don't do, they just throw them in. That can cause issues as well. So it's hard for people because I suppose they'll buy a set of gears online or off eBay or somewhere and they'll go to marry it up, and if it doesn't quite mesh right, it's hard to return, it's hard to get back onto the person, so they just throw in what they've got.
Yep.
But sometimes, more than likely, we find that that's the biggest issue with low oil pressure problems after people have gone and then modified their own oil pump.
So, what's the alternative?
Well,
I know, but yeah.
We've had these pumps out for a long time now. They sell really well. They're in a lot of cars.
I did actually notice before that you said aluminum. Is this from like dealing with all your American customers now? We're blaming Richard Holdner for that?
Quite possibly. I do watch a bit of YouTube when I finally make it home at night. House is dark and quiet, and I jump on the couch and catch up on the local goss.
So aluminum or aluminium for all the people that think that it's funny how us Australians say it. Anyway.
There's a lot of words that filter through. But yeah, so our pump is a little bit, actually in essence, you look at that, form-wise, they look quite similar. The inlet, outlet, pump, the gear location, the rotor location, the relief location, they're all pretty much in the same spot. There's a couple little tweaks we've made to the pump, which is just transitioning the inlet flow a little bit differently. The diameters of the inlet. Our pump housing runs a lot more diameter through here, and the material is far superior to that material anyway. So the fact that it's thicker and it's a better material doesn't allow the pump housing to flex at all.
Oh, and then you said that, and that's billet too. That's cast. So
yeah, it's a full billet pump.
Yeah.
We've had people in the past say, "Oh, that's a cast pump, this, that, rah, rah, rah," but you just have to have a look at all the machining marks right all over the whole pump.
Yep.
Just to understand that, yep, it's full of machining marks. They're all tool marks. The whole pump's actually a billet pump.
And we won't give it away, but there has been somebody that's ripped off a couple of your pumps too, but you won't mention what they've done because...
No, good luck to them.
Good luck to them because you can tell what the difference is and they can't. So
yeah, that's right. That's right. And I've got all our customers, when they go through engine builds and they do refreshes and whatnot, they all send the pumps back to us and we overhaul the pumps. It's part of our service and send them back out and get them back on the road again.
Serial numbers too as well. So
yeah, once we do them, we engrave a serial number in here and a date, usually an order number or whatnot, so we know who's bought the pump.
Yep.
We know the full history of them when they come in and out.
Yep.
Our relief is modified. Our diameters in here, our gear set, which I don't have, which I don't really want to put on screen anyway. That's all different. That's modified. Mark's going to have a special black edition of this pump on his car, which is our drag spec one. We've only really sell them to the guys that are at the top end and going to squeeze them.
And just for those people that want to know who Mark is, that's me, the guy in the headphones.
Yes.
Because I just call myself Boxer because it's easier. Anyway, back to this, yep.
So yeah, that's our pump. And that's what you'll be running on your car.
Nice. So, I mean, we're pretty much showed off. I mean, what else can we talk about here? Because we are running standard FG style sump.
Yeah. So we'll run a modified sump on this, obviously because it's got a one go over your cross member.
Yep.
But two, we also want to control the oil in the pan too. We don't want it moving around, moving away from the pickup. Because we're keeping this wet sump, very important thing with wet sump is that the oil is exactly in the location that we need it.
Yep.
The other very important thing is that the oil draining back from the block doesn't get hung up on the crank and actually makes it all the way back down into the pan again. Because at full noise, at sustained RPM, a lot of the oil can get stuck in the top end of the engine, and we need to get that back down to the pan again, and through the motor.
And I guess, I mean, looking underneath, I mean, it's probably a pain. I can give you a hand to flip this over, but...
That's all right.
Well, see, this guy does this for a living. Look. This is the one that Anth cleaned. I cleaned this one, and he did a much better job with this one. And ironically, this is the one that we're using. So, yeah.
Yes. Well, you said that after the first one, so then I cleaned everything else.
Yeah, I know.
Worked
Well, I mean,
well,
you've done more than I have, so you're
worked
better at
out
it.
really well.
I'm a caustic bath rookie, so do we do anything in the block? Is there any cleaning up or anything like that? Like you see a lot of dudes with V8s that get in there and machine out all the oil galleries and all that sort of stuff.
Yeah, look, where we need to remove material, we'll remove material. There's a couple little things that we do that everyone's got their own tricks and tips.
We'll just show you all the parts that he does.
Yes.
All of the, let's see, oh, yep, no, oh, yeah. So, no, just kidding. No, there are some secrets that...
There's some things that we like to do that, look, every single engine builder will have their own way of doing something different. And we've got ours, everyone's got theirs, and you know, just see what works at the end, really.
And I mean, so mainly though, under here we're going to be putting main studs in it and a girdle and sticking with the standard bearing caps.
Yeah, basically. So like I said before, we're trying to do 1,000 kilowatt we'll build, which when we discussed the goals that you wanted and the numbers that you want to run, with the weight of your car, the size of your turbo, I think we'll do it pretty comfortably by just building a factory cap motor, put some good parts in it, and give it some good tweaks and get everything working right. But yeah, I don't see why you can't do it with what we've got.
And I mean, you know, the thing is too now is that I'm kind of going down the path of having, you know, Nexus R5 ECU, which is proven and tested. I've got this hand thing in the shot. Plasma and Plenum, 6-boost manifold, Garrett turbo, all the good stuff that's been used time and time again that works. So there's no guesswork, no custom. It's just, you know, good engine with good parts on it. So
yeah, we're not doing anything stupid as far as leaning on it to try and kill it and run, you know, a 7-second pass or a 6-second pass. That will come in time if you want to go down that track. But we want to get the car to the track, run some decent numbers in it. You know, and build the engine to suit the horsepower level that we're aiming for.
Yeah.
Yeah.
Nice.